Hi everyone, my name is Molly. I'm a plant biologist by training and now work full-time as a science communicator. I go by Science IRL on the internet, and I collaborate with scientists to make videos about their research to share with public audiences. A big part of my job is using social media to tell these stories, and that's what I'll be talking about in this video. The benefits of using social media to share science, how to get started, and some tips and tricks I've learned in the 10 years I've been doing this. Let's get into it. Regardless of whether you're just getting started in research or are a seasoned professor, you might be wondering, what is the value of sharing my science on social media? First and foremost, it allows you to get your research out in the world. Let me show you an example of an Instagram reel I made about my PhD research. This one time in grad school, I was trying to quantify the shape of flower petals, and it got so crazy that applied mathematicians had to get involved. I studied columbine flowers. Their petals form nectar spurs to attract and reward pollinators. Bee-pollinated species have short, curvy spurs, and hummingbird-pollinated species have long, straight spurs. I wanted to find the genes responsible for this difference in spur shape. By crossing these two species together, we could create a population of their grandchildren that has tons of variation in spur shape. We sequenced the grandchildren's genomes, and I scanned 5,000 of their petals. But in order to find correlations between genome sequence and spur shape, I had to quantify the shape. How curvy were the spurs? Enter Dr. Gary Choi, applied mathematician. He developed the methodology for quantifying columbine flower nectar spur curvature. First, we chose a straight spurred petal to serve as the reference. For both the reference spur and the spur we were quantifying, Gary measured the slope of the spur edge at many points along its length, and then generated plots of the change in slope. By subtracting the area under the reference plot from the measurement plot, he could generate a number that represented curvature. The bigger the difference from the straight reference, the curvier the spur. I finally had curvature quantification data for all my spurs. By analyzing them together with my genome sequences, I found that there is a single gene controlling spur curvature. Biology and math can make some pretty amazing magic together. The cool thing about social media is that you can reach many audiences at once. So many different kinds of people use these platforms. Every time I post a video like that, I get messages asking for PDFs of my published papers from high school teachers, grad students, professors, you name it. More people have read my papers because of Instagram than because of any conference I attended. Second, you can use social media science communication to advocate for causes that are related to your work. Maybe that's climate change or global health or cancer biology. I make a lot of videos about bioengineering because there is so much misinformation about it out there, and I have the expertise to help tackle that. Here's a clip I made from a video with a lab at Purdue University about genetically modifying plantago plants.
In order to do the transformation experiment, we first have to introduce you to a new organism, Agrobacterium tumefaciens.
Agrobacterium is able to genetically transform plants, and it evolved this skill naturally. So it's been doing it for way longer than us humans have even been doing science.
Normally, it inserts its own genes into the plant's DNA, which tell the plant, hey, build me a huge house and fill it with a ton of delicious food. But scientists can swap out the house and food genes for ones that they actually want to study, and the agrobacteria will insert those genes into the plant instead.
This is really cool. I think we often picture gene transformation as this really artificial thing, but we're actually borrowing it from nature.
Every time I post a bioengineering video, it sparks conversations with folks who may have not been open to the idea before, provides a chance for people to ask genuine questions, and a chance for me to dispel misinformation. Third, sharing your own experience in research can help inspire and prepare the next generation of scientists. You're providing a gateway into the world of STEM. I make a lot of videos about my experience in grad school. Here's a TikTok where I talk about how insecure I was about learning how to code.
I embroidered the first graph I ever made in R with my own PhD data. Here is the graph in all its glory. But I was so proud that I had finally learned enough R to visualize my own data that I emailed my mentor Angie the second I made it. And now that I finished my PhD, I embroidered it as a thank you gift to her. I started graduate school with absolutely no coding experience, and I was convinced this put me miles behind my peers, and I was going to flunk out because I'd never be able to learn this late in the game. And Angie helped me get over my fear of coding and data analysis. She spent hours going through code with me, encouraged me to try things and make mistakes, and that I wouldn't blow up my computer if I messed up a line of code. She helped me realize that software manuals and tutorials are actually there to guide you, not scare you, and let me see that half of coding is just knowing what to Google. I'm a better and more confident scientist and learner because of her. And once I got the hang of R, that little graph became this figure in my first author publication. But I'm glad I can immortalize it forever in this embroidery, so I never forget where it all started.
Whenever I post a video like this, I get so many lovely comments and messages seeking advice about applying, what field to go into, people's hopes and dreams for the future. We can use social media to welcome people into STEM. And lastly, you'll gain so many transferable skills by communicating your science online. My writing and storytelling, figure making, public speaking all improved because I made videos at the same time I was working on my PhD. Doing science communication will help you be a better scientist. Those are some of my motivations for doing SciComm. Hopefully they resonated with you and got the wheels turning. Next, we're going to talk about how you get started making science social media content in the first place. I would think about a few key things: subject matter, format, and learning objectives. For subject matter, how niche are you going to go? Will your science communication be about biology, botany, plant systematics, or the flora of a specific country? Will it be more about general knowledge or specific research projects? Will you cover history or current updates from your field? If you're featuring the work of other scientists, I encourage you to think about whose stories you're telling and whose voices you're elevating. Social media allows us to get super creative with format. You can share your science through videos, infographics, text, art, comics, podcast, music, or some combination of these. Within each of these formats, there are endless possibilities to play with, and different social media platforms lend themselves better to certain styles and content. It's always useful to have learning objectives in mind to guide your content creation. These could be anything from, I want my audience to learn this really cool thing about plants, to, I want to convince my audience that this habitat needs to be conserved, to, I want my audience to feel like science is for them. Think about who your ideal audience is and tailor your content to them. Even though it will be broadcast far and wide on social media, you will eventually find your people. And it's helpful to have a plan for how you want to engage with your audience. Responding to positive comments and answering genuine questions helps drive more views and build community. But giving trolls your time and attention generally isn't worth it. Every once in a while, I'll push back if I think that exchange might be a useful example of how to counter misinformation, but my strategy is usually to ignore or block trolls. But I definitely don't want to make it sound like you have to have all of this completely figured out before you start creating. It took me a while to get in the groove with Science IRL, and I'm still experimenting with new formats and styles today. Just start making things and see what works and what feels good and what could use improvement. Don't worry about fancy equipment or software. You have everything you need to get started right there on your phone. And my absolute biggest piece of advice is to make something that you enjoy making, that you're passionate about, that you look forward to working on. That joy and creative spark will help you find your science voice on social media.